Welcome back. JAMB 2023 past question 6, physics. Yeah, a particle in simple harmonic motion while passing through the main position will have dash. A, minimum kinetic energy and maximum potential energy. B, maximum potential energy and minimum kinetic energy. C, minimum kinetic energy and minimum potential energy. D, maximum kinetic energy and minimum potential energy. Now, first of all, what is simple harmonic motion? That's the motion, or let me say the periodic motion of a body or a particle about a fixed point, such that its acceleration is always directed towards that fixed point and is proportional to its displacement from that fixed point. Now, the best way to explain this question for us to choose the right answer is to use a simple pendulum. We have different examples, many examples of substance or material that undergo simple harmonic motion. A good example is the simple pendulum, and then another example is the helical spring. So now, but for simple pendulum, let's use simple pendulum in this particular question. Let's say this is the fixed position, and then this is the bob of the pendulum. This is the length, swinging left and right, to be swinging left and right in a periodic manner. So as it is swinging, so you see the length. So this is where we are going to have the maximum displacement. This is the main position. From the center, this is the main position. Now, if you check, I can call this point A, call this point B, and call this point C. I can draw a horizontal line to join both A and B, so that from there I'll be able to know that there is a height between this point and the minimum position. Let me call it H. So let me call it H. From the lowest point to this point B, we can call it H. So over here at A and B, you can see that we have heights at A and B. As the pendulum is moving, swinging left and right, when it gets to point B, it will stop momentarily. No motion here, no velocity here, and it continues swing it before it starts moving back again. At this point, it will have maximum velocity because it will swing, it will move very fast away from this place. It will move very fast along this place. So when it gets to A again, it will stop. That means there is no velocity here. Now, the formula for potential energy is equal to mgh, while the formula for kinetic energy is half mv squared. At point A, where there is no velocity, that is where the velocity is equal to 0, and we have maximum height at A and B, that means we are going to have maximum potential energy here. The PE will be maximum because that's the maximum height from the equilibrium position. We have maximum height from here. So over here too, we are going to have PE, potential energy, or maximum potential energy. Now, over here, since there is no velocity, that is, the velocity is 0 at both A and B, that means we have minimum kinetic energy. Over here too, we have minimum kinetic energy. Now, here that we can refer to it as the lowest point. There is no height at this point at all. You can see it's the lowest point. Height is 0 here. If we substitute 0 in the formula, we are going to have 0 for potential energy. That means we have minimum PE at point C, and then we have maximum KE. That's maximum kinetic energy. So to answer this question, the question is saying when the particle passes through the main position, this is the main position. Point A and B are not the main position. Point C is the main position. So what happens there? We have minimum PE and maximum KE. Minimum potential energy and maximum kinetic energy. Let's check the option that corresponds. Option A, minimum kinetic energy, no. Option B, maximum potential energy and minimum kinetic, no. Option C, minimum kinetic, no. Option D, maximum kinetic energy and minimum potential energy. Thank you for viewing this. God bless you.